Okay, students, in this lesson we are looking at graphing exponential functions. And before we get started, let's look at something like this. If I have 2 to the negative 1, remember this is equal to 1 over 2. If I have 2 to the negative 3, for example, this is equal to 1 over 2 to the third, which is equal to 1 over 8. So keep that in mind. Today we're looking at graphing exponential functions. This is the format y equals b to the x. If this variable, or if this exponent is a variable, then we know for sure this is going to either increase very rapidly, exponentially, or decrease very rapidly. This number here, the b, or the number that it's next to the exponent, if b is more than 1, we say this function is going to increase very quickly. So this is going to be an exponential growth, all right? It's going to grow very quickly. If we have b and b is more than 0 but less than 1, in other words, if it's a fraction such as half, a third, or any decimal between 0 and 1, then we call this an exponential decay. Exponential decay, all right? So that's how you can tell whether something increases or decreases very rapidly. So the example here, y equals 2 to the x. This number, which we call the base, is more than 1. So we know this is going to increase very, very rapidly. So let's make a table really quick. Choose values for x. I always do simple ones, -1, 0, 1. But be wise as to what numbers you choose to make this easier. 2 to the 0, well, 2 to the 0 is always 1. Keep that in mind. 2 to the first is 2. 2 to the -1 is a half. So if I take these numbers and I plot them, 0, 1/2 right there, 1, 2, and -1, -1/2. Actually, I wrote that incorrectly. It's 0, 1 right there, and -1/2. So the graph looks something like this, all right? This is going to go on forever. Now on the left side, we can try this. Oops, I'm not sure what happened here. My pen is going crazy, guys. I apologize about that. Okay. Let's erase this. This is a new program I'm trying out, guys, so bear with me. Let's get rid of all this. Alright, and let me make that table again. So we want to know what it looks like on this side. So we can choose values for x. Let's say -3. 2 to the -3, it's going to be 1/8. So 1/8 is half of a quarter. So way over here, very small, right? If you choose -4, 2 to the -4 is going to be 1/16. It's going to get smaller, smaller, smaller. It never actually touches 0. It appears like it's going to be touching 0, but it never goes over that line, right? So this graph, it approaches 0, but it never really touches that 0, all right? It actually never goes over this line right here. It never goes over this line. We call this line a restriction line, or the official name is an asymptote. An asymptote is basically a restriction line where the graph does not go over. So this asymptote here, if you notice, is going to be y equals 0. This line right here, this line is y equals 0. That is what we call an asymptote. And if I was looking for the domain of this graph, it's going to be all real numbers. The range, it's going to be, well, the range is going to be anything greater than 0. not equal to, it doesn't touch 0, more than 0, or you can say all positive numbers. That includes decimals too. All right, let's look at one where it's a decay. All right, let's move this up. And actually, maybe let's do another table, another graph. Let's clear all this. All right, so let's do another one. And by the way, if you want to see the actual graph, y equals 2 to the or 2 to the x. Let me erase this. 2 to the x. See that? It never actually touches 0. It appears like it's going to be touching 0, but it never really touches it. Let's look at another one. Let's do it by hand, and then we'll look at the graph. So let's see. Let's erase this up here. Let's do one by hand. Why is it doing that? Okay. Erase. Okay, let's do one by hand. Let's do y is equal to 1/2 to the x. Okay, notice this base here is less than 1 but more than 0, so we know this is going to be a decay function. And let's make a table really quick so we can see. Choose values for x. Let's do -1, 0, 1. See what happens. So if I take -1, plug it in, guys. So you got 1/2 to the -1. That right there basically means you have to just put all the under 1, which ultimately it's going to be flipped. So you get 2. Take 0, plug it in. What's 1/2 to the 0? 1. What's 1 plugged in? 1/2 to the first? It's going to be 1/2. And I can keep going. Take 2, for example. What's 1/2 to the second? Well, 1/4. And by the way, you can take your time, analyze why this is the case. So we have -1, 2, right about there. We have 0, 1. We have 1, 1/2. We have 2, 1/4. And look what's happening here. This is just decreasing. It's decreasing each time, more and more and more. But it really never is going to touch 0, ever. So again, we have another asymptote. Remember asymptote? It's a line that it's like a barrier. This graph does not go over that line. This is another asymptote. And that asymptote is y equals 0. Okay. Domain. Well, domain is also all real numbers. Range is going to be anything greater than greater than 0. And that's it. Let's look at the table. Let's look at the actual graph so you can see what it looks like. Let's do 1/2, not 20. Let's do 1/2 to the x. And let's see if we can graph this. There it is in green. You see that? Boom. All right. So let's let me go back to tools and let's clear all this. There's one more thing that I need to go over with you. All right. Delete. Okay. So let me go back to the first equation I had. 2 to the x. All right, 2 to the x. Let's leave that one right there. And all right, so if I have another graph, y equals 2 to the x plus 1 minus 6, okay? We know that this one here is y equals 2 to the x. But then how do we graph this? Well, this right here will be a variation of this one up here. All right, so just graph 2 to the x, and then, just like everything else, this right here tells you that you need to move this to the left. Left 1 unit, that's going to be your horizontal change. And the number on the outside is that vertical change, down 6. All right, down 6. In most of these examples, the number on the outside is considered the k. Right? The horizontal change here, we use an h. All right, so keep that in mind. So how do we graph this? Well, we have a bunch of points here. We have a point here that we know it's 0, 1. We know this is 1, 2. We know this is negative 1 half. So we can move everything to the left 1 unit, and then down 6, so way down here. All right, again, down 1 unit, down 6. Down 1 unit, down 6. So, and I apologize for this graph, but it will be somewhere down here. Let me go back to the graph, and let's exit this, and let me graph it for you guys. Here we go. This is what it's going to look like. 2 to the 2 to the x plus 1 minus 6. All right, notice that was moved down here. And now look, the everything changed. The asymptote changed. It's not the same anymore. The asymptote is now down here. This is the asymptote. All right, the asymptote is y equals negative 6. That's that restriction. What's the domain? Well, the domain is still all real numbers. What's the range? The range is going to be anything greater than negative 6, and so on. All right, and I'm not sure why this was deleted, but this was this function here. This is y equals 2 to the x plus 1 minus 6. The original one we had up here was y equals 2 to the x. I hope this makes sense. Please let me know if you have any questions.